In this video, we're going to be looking at central and inscribed. So we have a typo up here, inscribed angles. So we talked about circle vocabulary and that a central angle has the vertex at the center at the circle. And if we have an inscribed angle, the vertex of the angle is on the circle. It's going to be very important as you're working with these two types of angles that you identify where the vertex is located so that you know which relationship it is that you're using. So if you look at our central angle, the measure of our central angle is in degrees. So 80 degrees at the center of the circle, and then this is our arc measure. Arc measure is the measure of this curved part of the circle that is cut by the sides of the angle. So this arc is created by the angle. It's a central angle, and if you notice, the arc measure is equal to the angle measure. So for a central angle, you find the angle that creates the arc. Whatever the measure of that angle is, the measure of the arc is going to be the same. For the inscribed angle, where the vertex is on the circle, again, the angle is creating this arc. So wherever those two lines intersect the circle, that's where we've created the arc. In this second picture, we actually have a tangent line and a chord creating the inscribed angle. But we notice the relationship is still the same, that we take the arc measure and it is going to be equal to 2 times the angle. We can also say that the angle is equal to the arc measure divided by 2. So we're doubling. So we go from 40 to 80 and from 75 to 150. But this is why it's really important to know which type of angle you're looking at as to whether we need to deal with a half or doubling, or if we're just going to say that those two things are equal. For example number 1, this is a central angle because the vertex of that angle is in the center of the circle. So for a central angle, remember that the arc is equal to the angle. So if the angle is 160 degrees, the arc is also going to be 160 degrees. Example 2, this is an inscribed angle because the vertex is on the circle. And again, it's one where we have a chord and a tangent line. We would still use that relationship that the arc is going to be the angle times 2. So we would double. So if the angle is 100, 100 times 2 is 200. And again, it's in degrees. So arc measure and angle measures are going to both be measured in degrees. Number 3, we actually have 2 inscribed angles. One thing to note here is that we have 2 angles, but they're both intersecting the same arc. So if 2 inscribed angles intersect the same arc, that means they have to be congruent. And again, the relationship is that the arc measure is double the angle. So 68 times 2 would give us 136. Because that's also intercepting the same arc at 136, we can work backwards and say that 136 divided by 2 is going to give me the angle labeled as x, which again would be 68 degrees. In number 4, they want us to find all arcs and angles. So we're going to have to put some things together that we know about this circle. And this radius should actually be here. So remember, total in the circle, we have 360 degrees. If it's a diameter, meaning it's cutting through the center point of the circle, it's a semicircle, so it would have 180 degrees. So we can kind of start to put some of those things together. So these angles would have to add to 180 because they sit on that diameter. And they would all have to add up to 180, so we can add the 52 and the 64. Maybe not trust my math too much right now, so double check it with the calculator. So 116. Subtract that from 180. So that angle should also be 64. These are central angles because their vertices are sitting at the center point, which means their arc also has to be the same measure. So we call it the intercepted arc. So the first angle that we found, that was 64 and 64, with this angle over here is again another semicircle, so they would have to add up to 180. So I can subtract what I know. So 64 and take away 64, this is going to be 52. So the arc and the angle would be 52. Remember that the whole circle is 360. So I found everything here except for this one large angle. So I can say 360, take away the rest. And that's going to give me what is left over. So let's see, we had 52, 52, 64, 64, so I'm just subtracting, and that is going to be 128 degrees, and it would also be 128 on the arc. So what I kind of like about circles and some of the geometry stuff, it's a little bit like a puzzle. It's, you know, what do I know? What can I use to help me solve for what's missing? And you know a lot more than you think that you know. There's a lot that you learned in middle school that you just probably haven't used in a long time. So let's work a couple of example problems. So again, we identify the type. So in number 1, this is a central angle. A central angle, its angle measures equal to the arc. So if it's 160 at the center, it also has to be 160 at the arc. Number 2 is an inscribed angle because the vertex is sitting on the circle. So we have the angle measure, we're working to the arc, so we're going to double the angle measure to get to the arc measure. So that's going to be 140. So again, in number 3, this is some of the puzzle piece, right? So they don't give me the arc measure that relates to what the angle is they want me to find. They gave me the other side. Well, I know there's still 360 degrees, so 230 is accounted for, so this is going to be 360 take away 230, which is going to be 130. And they're the same measure, so that's my answer. In number 4, again, we have 2 congruent angles intercepting the same arc. They're both 52, so we double the angle measure because it's an inscribed angle to give us our arc measure of 104. So don't forget, on these ones that are a tangent line and a chord, we still treat that as an inscribed angle. So my angle is 165. To get to the arc, we have to double that. So 2 times 165 is 330. Maybe? Yep, well, I can still math. We're good. So that would be 330 degrees. So I think the rest of those examples are pretty straightforward. We'll work some together in class, but again, you just want to make sure that you can identify which type of angle it is and then what relationship that you're going to be using to find what's missing.